A ship sails from Port R on a bearing of 65 degrees to Port S, a distance of 54 kilometers. It then sails on a bearing of 155 degrees from Port S to Port Q, a distance of 80 kilometers. Find, correct to one decimal place, I, the distance between R and Q. II, the bearing of Q from R. As we learned in the previous video, whenever you are being given a question like this, the first thing you need to do is to read the statement carefully and then draw an appropriate diagram for the statement. So, let's go over the question again. A ship sails from Port R on a bearing of 65 degrees to Port S, a distance of 54 kilometers. It then sails on a bearing of 155 degrees from Port S to Port Q, a distance of 80 kilometers. So we are going to draw a diagram to represent this information that has been given to us. So the ship started sailing from point R. So it means that our starting point is going to be Port R or point R. Now it started from Port R and it sailed on a bearing of 65 degrees to Port S. So our starting point is Port R or point R on a bearing of 65 degrees, and the ending point is Port S. And the distance between Port R and Port S is 54 kilometers. So let's draw the diagram for this first part. So you are going to consider for this first part, then after that you consider the rest. Okay, so the ship started from Port R. So you draw our X and Y plane here, then we indicate here as R or Port R. It started sailing on a bearing of 65 degrees. So we measure 65 degrees from 0. So here's the 0 line. Don't forget that. Here is 0 degrees. Here is 90. Here is 90 degrees. Sorry. Here is 180. Oh, sorry. And here is 270. Okay, so here is 0, 90, 180, and 270. So it started on a bearing of 65 degrees. So it started from 0 here, 65 degrees. Then you draw the line through it. It started from Port R to Port S. It started from Port R to Port S. Now the distance between Port R and Port S is 54 kilometers. The distance between Port R and Port S is 54 kilometers. So the ship started sailing from Port R on a bearing of 65 degrees to Port S, and the distance between Port R and Port S is 54 kilometers. So we are done with the first part. Let's go on to the second part. It says that it then sails on a bearing of 155 degrees from Port S. So for the second part of the journey, it started from Port S. That is why I've drawn the X and Y plane on Port S. So this ship started sailing in the second part of the journey. It started from Port S to Port Q. So the starting point is Port S. The ending point is Port Q on a bearing of 155 degrees. So you are going to measure 155 degrees from Port S. We know that also on Port S, here will be 0, here is 90, here is 180, here is 180, and here is 270. Now we know that 155 is between 90 and 180. So it's going to be in this region or in this quadrant. Okay, so you ask yourself, what should you add to 90 degrees in order to get 155 degrees? And you are going to get that by subtracting 90 degrees from 155 as we've been doing all along. And when you do that, you see that you are going to get 65 degrees, because 65 degrees plus 90 degrees will give you 155 degrees. So it means that you are going to measure 65 degrees from 90 here in the clockwise direction. Then you draw your line through it. As I said in the previous video, make sure that your diagram is appropriate. We know that from 90 to 180 here, the total angle is 90 degrees. 65 degrees is more than half of 90 degrees. So draw something that represents more than half of 90 degrees. You are not going to get it accurately because you are not drawing it to scale, but make sure that your diagram is appropriate. So 65 degrees is more than half, it must be shown that it's more than half. So you draw something that is about 65 degrees. Then you draw your line here. The starting point is S and the ending point is Q. Now you see where the arrow is moving towards, showing that it started from S to Q. So in the first part of the journey, it started from R to S. Then the second part of the journey, it started from S to Q. So you have been able to illustrate this information here on the diagram. It says that from port S to port Q, a distance of 80 kilometers. So from port S to port Q is 80 kilometers. Once again, on this diagram, you can see that from R to S is 54 kilometers. From S to Q is 80 kilometers. So make sure that the 80 kilometers is longer than 50 kilometers, because 80 kilometers is longer than 50 kilometers. So don't draw them as the same length, or don't make the 54 kilometers longer than 80 kilometers. When you do that, your diagram will be inappropriate and it's going to affect the answer that you are going to get. The question goes on to say that we should correct to one decimal place the distance between R and Q. So the question wants us to find the distance between R and Q and the bearing of Q from R. To find the distance between R and Q and the bearing of Q from R. So let's start with the first part. Find the distance between R and Q. In the introductory video on solving distance bearing problems, we said that after you've drawn the diagram for the question, the next thing you need to do is to form right-angled triangles from the question. So in order to do that, you have to find the interior angles of the triangle. So you find the interior angles from the triangle that is possible to find using geometry. So this is what I mean. We know from this diagram here that this point here is the 90-degree point. Here is the 180 degrees point. So the total angles between this point here is 90 degrees. So if here is 65 degrees, then this other angle, that is the smaller angle here, is going to be 90 degrees minus 65 degrees, which will give us 25 degrees. So you have been able to find this angle here. Let's see if we can find this other angle. Now look at something. This line here, this vertical line passing through R and this vertical line passing through S, these two lines are parallel lines. If they are parallel lines, then the line RS is a transversal crossing the two parallel lines. Because the line RS is a transversal crossing the two parallel lines, we can say that the angle that is created here, which is 65 degrees, and the angle that will be created here will be alternating angles. We know that alternating angles are equal. So if here is 65 degrees, then this angle is also 65 degrees. Once again, I have explained alternating angles and all the other angle properties of parallel lines under the video in plane geometry. So if you watch that video, you are going to get more knowledge about how to find alternating angles and all the other angles too. Okay, so we have here to be 65 degrees and here to be 25 degrees. 65 degrees plus 25 degrees will give us 90 degrees. So it means that in this triangle here, triangle RSQ, this side here, the angle on S is our right-angled triangle. So from here, I'm going to draw a small right angle triangle that I'll be using for my calculations. Now on this small right angle triangle, because here is x, because x has the right angle on it, I'm going to indicate that in the diagram. So this point here, point S, has the right angle on it. So point S with the right angle, as can be seen here. Now we know that the distance between S and Q is 80 kilometers. So from the diagram, the distance between S and Q is 80 kilometers. So I will indicate that here, 80 kilometers. We also know that the distance between S and R is 54 kilometers. So I will indicate that one also on the diagram. The distance between S and R is 54 kilometers. The question told us to find the distance between Q and R. So we have a right angle triangle. We know two sides and we want to find another. We can apply the Pythagoras theorem to help us solve this question. In the video on trigonometry, we explained the Pythagoras theorem. We are going to use the knowledge that we got from trigonometry, from Pythagoras theorem under trigonometry to solve this question. We know from the Pythagoras theorem that the square of the hypotenuse, or the longest side, is equal to the sum of the squares of the other two sides. So what this means is that if you come to this triangle here, the square of the longest side, which is RQ, that is the line that we are interested in, the square of that line is equal to the sum of the squares of the other two sides. So the square of RS plus the square of SQ. Okay, so after we have been able to quote this formula, all we need to do is to substitute our values in it. We are looking for RQ. So RQ squared is equal to RS is 54, so 54 squared plus SQ, which is 80, so 80 squared. RQ squared is equal to 54 squared plus 80 squared will give us 39316. So what do you do here in order to find RQ? You take square roots of both sides. So you take square root of the left hand side, then you take square root of the right hand side. Now as soon as you do that, we know from change of subject that if you take square root of this side here, now the squared here will cancel the squared here. We learned this in change of subject, and we also learned it under indices. So the squared here will cancel the squared here. So RQ is equal to 96.5 kilometers. Now you can see that when you find the square root of 9316 on your calculator, the value does not end at 0.5, it continues. But because the question told us to round our answer to one decimal place, you are going to round your answer to just one decimal place here. If you want to learn how to round your answer to the nearest decimal place, watch the video on approximations. There I explain how to do it, and how to do it manually, and also how to use the calculator to do it. So if you watch that video, you are going to get more knowledge about how to round your answer to the nearest decimal place. So we can say that the distance between port R and port Q is 96.5 kilometers. The second part of our question says that we should find the bearing of Q from R. We are going to find the bearing of port Q from port R. Now, to find the bearing of port Q from R, we know that the bearing of port Q from port R will be measured from the zero line of port R in the clockwise direction up to the line joining port R to port Q. So it means that we are going to measure it from this side here straight up to this side here. But we know one thing. We know that this angle here has already been found to be 65 degrees. We already know this angle here to be 65 degrees. So what is left of us to do is to find this angle here. If you're able to find this angle here indicated with the red color, we add it to the angle here which is indicated with the blue color, that is 65 degrees, and we'll be able to find the bearing of port Q from port R. Okay, so how do we find that angle here? the angle indicated with red as shown in this diagram. How are we going to find it? I'm going to call that angle theta. I'm going to call this angle here angle theta. So if I call this angle here angle theta on this diagram, on this right angle triangle, I can also indicate theta here. Now look at something. You see that theta, you can see that theta is the angle formed on port R. So here the angle on port R is also theta. I want to find the value of theta. Considering theta, 80 kilometers is opposite, 54 kilometers is adjacent. Considering the angle theta, you can see that 80 kilometers is opposite to theta, 54 kilometers is adjacent to theta. In order to find theta, I'll have to use one of the three trigonometric ratios we've learned under trigonometry: cos, sine, and tan. Now, I have opposite and adjacent. We know that if you have opposite and adjacent, the trigonometric ratio that you have to use is tan, because tan will give you opposite over adjacent. So here, to help us find theta, I'm going to use tan. Okay, so as soon as we are able to find theta, we can say that the bearing of port Q from port R will give us 60 degrees plus theta. So let's find theta. From the right angle triangle, we can say that theta tan theta is equal to opposite, which is 80 kilometers, divided by adjacent, which is 54 kilometers. So the kilometer will cancel the kilometer. How do we find theta? We can say that theta is equal to tan inverse of 80 divided by 54. So all we need to do is to find the tan inverse of 80 divided by 54. We know how to do that, right? You press on shift, then you press on tan. Then you bring your division sign, 80 divided by 54. From there, you close the bracket, and tan theta is giving us 55.980. It goes on and on. Remember, the question said that we should leave our answer in one decimal place. So here I round this. If you are leaving your answer in one decimal place here, you will see that you add 1 to 9. When you add 1 to 9, it becomes 0. So you transfer it to this side, which becomes 56. As I said, if you want to learn how to do this, watch the video on approximations. I explain that into details. So leaving our answer in one decimal place, you are going to have 56 degrees or 56 degrees point 0, which is the same thing. So we have found theta. But theta is not the bearing of port Q from port R. We know that the bearing of port Q from port R is 65 degrees plus theta. We have found theta to be 56 degrees. So what do? The bearing of port Q from port R is equal to 65 degrees plus theta, which is now 56 degrees. And this is going to give us 121 degrees. So we can say that the bearing of port Q from port R is 121 degrees. Two cyclists left a point P at the same time. The first cyclist covered 300 meters on a bearing of 296 degrees, and the second cyclist covered 250 meters on a bearing of 206 degrees. Calculate. Correct with three significant figures. A. The distance between the two cyclists. B. The bearing of the second cyclist from the first. Okay, so let's solve this. As we said, whenever you are being given the question, you read it carefully, then you draw an appropriate diagram for it. So let's read the question again. Two cyclists left a point P at the same time. The first cyclist covered 300 meters on a bearing of 296 degrees, and the second cyclist covered 250 meters on a bearing of 206 degrees. So we need to draw a diagram to represent this statement that has been given to us. Now what we do is that, since we are being given first cyclist and second cyclist, I would like to use letters to represent them so that when I'm indicating it on the diagram, it will be easy. So I'm going to call the first cyclist A and I'll call the second cyclist B. Okay, so A and B left P at the same time. P is the point. So A and B, both of them left P at the same time. So it means that for both of them, their starting point is point P. So I'll draw my diagram here for point P. So I have the X and Y plane here. So this is point P. Let's first do it for A, which is the first cyclist. So he covered a distance of 300 meters on a bearing of 296 degrees. On a bearing of 296 degrees. We know from this diagram that here is 270 degrees and here is 360 degrees. So 296 degrees will be between 270 degrees and 360 degrees. So you ask yourself, what should you add to 270 degrees in order to get 296? And that will be 26. If you add 26 degrees to 270 degrees, you are going to get 296. I assume that by this time you are conversant with drawing these bearings on the diagrams because you've done a lot of them. Okay, so here is 26 degrees. So this is the bearing of the first cyclist, which I'm going to call A. So I'm calling the starting point here point P. That's what the question told us. So the ending point, I'm calling it point A because that is where the cyclist is. The distance between the starting point and where the first cyclist is, which is A, is 300 meters. So you indicate it there. The second cyclist also left P. So it means that the bearing of the second cyclist will be taken from the same point, which is P. And the bearing is 206 degrees. So you take 206 degrees from P. We know that from this side here, which is 0, up to this side is 180. So 206 is between 180 degrees and 270 degrees. So you ask yourself, what should you add to 180 degrees in order to get 206 degrees? And that will be 206 degrees minus 180 degrees. That will give us another 26 degrees. If you add 26 degrees to 180 degrees, you get 206 degrees. So this is the bearing of the second cyclist from P to B, and the distance, he covered a distance of 250 meters. Okay, so this is the diagram that will be used to represent the first cyclist and the second cyclist. The question says that we should find the distance between the two cyclists. So from point A to point B. Remember that point A is the first cyclist and point B is the second cyclist. It also says that we should find the bearing of the second cyclist from the first. So you should find the bearing of B from A. You are going to find the bearing of B from A. Our time is up for this video. See you in the next video where we will solve the first part of our question, finding the distance between the two cyclists. Bye-bye. We are going to learn how to find the distance between the two cyclists. Remember, in the previous video, we said that we are calling the first cyclist A and the second cyclist B. So if you are finding the distance between the two cyclists, what we are doing is finding the distance AB. So how do we find the distance AB? As we said in the introductory video on solving distance bearing problems, we said that after you've drawn the diagram, you form right-angled triangles from the diagram. To form the right-angled triangles, you have to make sure that you find the angle that has the 90 degrees. So here, we can see that this side here is 26 degrees. We already know that. Now, we know that this point here, now this is what I'm talking about. This point here is the 270 degree point here. Okay, so here's the 270 degrees point if you are taking the bearing from P in the clockwise direction. Here is the 180 degree point. Now you can see that between 270 degrees and 180 degrees, the total angle there will be 90 degrees. So the total angles here is 90 degrees. But what do we see? We know that this side here is 26 degrees. This small angle here is 26 degrees. We know that from the previous slide. We found that from our diagram. So if you want this whole angle here, we have to subtract 26 degrees from 90 degrees because we know that the whole thing is 90 degrees. So if this small part is 26 degrees, then we have to subtract 26 degrees from 90 degrees in order to get the bigger portion. Okay, so we are going to do that, and when you do that, you are going to get 64 degrees. You are going to have 64 degrees. 26 degrees plus 64 degrees will give us 90 degrees. So it means that in this diagram, the 90 degrees falls on point P. The 90 degrees falls on point P. So if I draw the small right angle triangle here, I'll call P here as the point where my 90 degrees falls on. So P will be here. Now the letter found here is A, so you indicate that here as also A. From P to A is 300 meters, so indicate it here, 300 meters. The other letter is B, so indicate that one also as B. So from P to B is 250 meters on the diagram, so indicate that one also here. We are interested in finding the distance between A and B, that is finding the length of AB. We can use the Pythagoras theorem. We know from the Pythagoras theorem that in a right-angled triangle, the square of the hypotenuse or the longer side is equal to the sum of the squares of the other two sides. So in this right-angled triangle, the square of AB, which is AB squared, is equal to the sum of the squares of the other two sides. So it's equal to PB squared plus PA squared. So AB squared is equal to PB is 250 meters, so 250 squared plus PA is 300 meters, so 300 squared. AB squared is equal to 250 squared plus 300 squared will give us 152500. What you do here is that you take square root of the left hand side and you take square root of the right hand side, and AB is going to give us 391 meters. Once again, if you take square root of 152500, you are going to get 390.51. So you see that you'll be getting a lot of decimals. We rounded our answer to 391 meters because the calculator told us to leave our answer in 3 significant figures. If you want to learn how to round your answer to significant figures, watch the video on approximations. I explained how to do that manually and how to also use the calculator to do that. So if you watch that video, you are going to get more knowledge about it. So when you round this answer here to 3 significant figures, we are going to get 391 meters. So we can say that the distance between the first cyclist and the second cyclist is 391 meters. The second part of our question says that we should find the bearing of the second cyclist from the first cyclist. How do we do that? Now these are the two diagrams that we already have. So we have the first diagram and we have the right angled triangle that we formed from the diagram. So if you are finding the bearing from the second cyclist, which is B, from A, the first thing we need to do is to draw our x and y plane on A, because that is where we are taking the bearing from. So the bearing of the first cyclist from the second cyclist will be taken from this zero line in the clockwise direction up onto the line joining A to B. So the bearing will be taken from this side straight up onto this side. But what do we know? we know that from this side here to this side here is 90 degrees. So from here to here is 90 degrees. That one we know. We know that to be 90 degrees. Okay, so what is left for us to find is this angle here, then this angle here. If you find those two angles, we can add it to 90 degrees to get the bearing of the second cyclist B from A. Okay, so let's go ahead and find those two angles. Now we can see from the diagram that as soon as we draw this x and y plane here, the horizontal line here and this horizontal line are parallel lines. This horizontal line here and this one are parallel lines. Now because they are parallel lines, we can say that line AP is a transversal. And if line AP is a transversal, then the angle created here and the angle created here are alternating angles. What do we know about alternating angles? We know that alternating angles are equal. So if here is 26 degrees, then the angle formed here is also going to be 26 degrees. So we found this angle. We already know the top part here to be 90 degrees. We have been able to find this angle to be 26 degrees. So what is left for us to find is this angle here. This angle is in the triangle, so we can use one of our trig ratios to find it. So what I'm going to do is that I'll call this angle here theta. The angle on A, I'll call it theta. Now you can see from this diagram that theta is the angle formed at A. So when I come to this right angle triangle, I can also call the angle formed at A as theta. So which trig ratio can I use to solve this? Considering theta, you can see that 250 degrees is opposite. 250 meters, not degrees. 250 meters is opposite. 300 meters is adjacent. So I have opposite and I have adjacent. It means that the trig ratio that I have to use is tan, because tan theta will give me opposite over adjacent. So you can see from here that as soon as I'm able to find theta, I can add 90 degrees to 26 degrees to theta in order to get the bearing of B from A. So the bearing of the second cyclist, which is B, from the first cyclist, which is A, will give us 90 degrees plus 26 degrees plus theta. So what I need to find now is theta. From the right angle triangle here, we can see that tan theta is equal to opposite, which is 250 meters, divided by adjacent, which is 300 meters. So the meters will cancel each other off. From here, in order to find tan theta, I'll take tan inverse of both sides. And when you do that, theta is equal to tan inverse of 250 degrees divided by 300 degrees. We know how to find tan inverse of a number. So all you need to do is to switch on your calculator. You press shift tan, you bring the fraction 250 meters divided by 300 meters, and this is going to give us 39.8055. It goes on and on. Remember, the question said we should leave our answer in 3 significant figures. So in leaving this answer in 3 significant figures, you get 39.8. Once again, if you want to learn how to round your answer to significant figures, a given significant figure, watch the video on approximation. I explained it there. I also taught how to use the calculator to round your answer to a given significant figure. When you watch that video, you get more information about it. So we have now found theta to be 39.8 degrees. We can now find the bearing of the second cyclist from the first cyclist, which is 90 degrees plus 26 degrees plus theta. This is going to be 90 degrees plus 26 degrees plus theta, which is 39.8 degrees. And when you add everything, you are going to get 155.8 degrees. So the bearing of the second cyclist B from the first cyclist A is 155.8 degrees. 3 times P, Q, and R are such that the distance between P and Q is 50 kilometers. and the distance between P and R is 90 kilometers. If the bearing of Q from P is 65 degrees and the bearing of R from P is 335 degrees, find, correct to the nearest whole number, I, the distance between Q and R, II, the bearing of R from Q. So let's take the question again. Now this time we are going to represent this information here on a diagram as we've been doing all along. So after you've read the question, you draw an appropriate diagram for the question. So it says that the bearing of Q from P is 65 degrees. We can represent that on a diagram. So the bearing of Q from P is 65 degrees, as can be seen here. And the bearing of R from P is 335 degrees. So we know that R, we are looking for the bearing of R from P. So we are still taking the bearing from P. So 335 degrees will be between 270 degrees and 360 degrees. So it will be in this quadrant. So now don't forget that the distance from P to Q is 50 kilometers. So it indicates that on the bearing or on the line that you draw. We go back to the bearing of R from P. The bearing of R from P is 335 degrees. It will be between 270 degrees and 360 degrees. And we know that if we add 65 degrees to 270 degrees, we are going to get 335 degrees. So you draw that it starts from P and ends at R, and the distance is 90 kilometers because it says that the distance between P and R is 90 kilometers. So it indicates that also on the diagram. Now the question says that we should find the distance between Q and R. So we are looking for this distance between Q and R. That is what we are looking for. So as soon as you finish drawing the diagram, you see that finding the distance between Q and R becomes very easy for us. The next part of the question also says that we should find the bearing of R from Q. So let's take the first part of our question, finding the distance between Q and R. As you've been doing all along, after you've drawn the diagram for it like this, you have to go ahead and form right-angled triangles from the diagram. Now, in order to do that, we need to find this angle here. We know that this point here is the 270 degree point. Here is the 360 degree point or the 0 degree point. We know that the difference between the total angles here between the 270 degree point and the 360 degree point is 90 degrees. But this side here is 65 degrees. So if here is 65 degrees, we can find this angle here to be 25 degrees. We know this angle here to be 25 degrees and this angle here to be 65 degrees. 25 degrees plus 65 degrees will give us 90 degrees. So it means that if you draw our right-angled triangle from this diagram, we can say that the 90 degrees is formed on P. So P is the side with the 90 degrees. Then I'll call this side here Q. The distance between P and Q is 50 kilometers, so I'll indicate it here. The other point is point R, so this point here, which is point R. The distance between P and R is 90 kilometers, so I'll indicate that one also here, 90 kilometers. Now the question wants us to find the distance between Q and R. As we've been doing all along, we are going to use the Pythagoras theorem. We know that applying the Pythagoras theorem on this triangle, QR squared is equal to QP squared plus PR squared. We want to find QR, so we substitute these values QP and PR into this formula that we've written. So QR squared is equal to QP is 50, so 50 squared. PR is 90, so 90 squared. QR squared is equal to 50 squared plus 90 squared will give us 10600. You take square root of both sides. So you take square root of the left hand side and you take square root of the right hand side. and when you do that, QR is going to give you 103 kilometers. So we can say that the distance between town Q and town R is 103 kilometers. The next part of our question says that we should find the bearing of R from P. You should find the bearing of P from R. So that is what we are going to do next. Because we are going to take the bearing from town Q, we will draw our simple x and y plane on Q, that is point Q, because that is where we are taking the bearing from. Now, what is the bearing of town R from town Q? We know that we will measure the bearing from this point here in the clockwise direction up to the line joining Q to R. Okay, but we know that from this point here up to this point here is 80 degrees, is 180 degrees. So what we need to find is this angle here and this angle here. If you're able to find those two angles, you add it to 180 degrees to get the bearing of town R from town Q. Okay, so let's work on finding the first part, which is this angle here. Now look at something here. The vertical line, this vertical line that passes through P, and this vertical line that passes through Q. These two lines are parallel lines. So it means that line PQ is a transversal. So if these two lines are parallel lines and line PQ is a transversal, from the angle properties of parallel lines, we know that the angle created here, which is 65 degrees, and this angle here are alternating angles. And because alternating angles are equal, the angle created here is also going to be 65 degrees. So right now we found one part of what we are looking for. We know that from this point here to this point here is 180 degrees. We have been able to find this part here as also 65 degrees. So what we are now looking for is this angle, because if you're able to find this angle, we can add it to 65 degrees and this 180 degrees. Okay, so how do we find this angle here? In order to find that angle, since it is in the triangle, I am going to call that angle the theta. So now you can see that theta is the angle created at point Q. So on the right angle triangle, or in the right angle triangle, theta will be here, the angle formed at point Q. So theta is the angle formed at point Q. How do we find the value of theta? We can use one of the trig ratios that we've learned. So you are going to use one of the trig ratios that we've learned. We know that considering this angle here, which is theta, 90 degrees is opposite and 50 degrees is adjacent. So 90 degrees is opposite, 50 degrees is adjacent. If you have opposite and adjacent, what trig ratio can you use? I'm going to use tan, because tan will give me opposite over adjacent. So from here we can say that the bearing of town R from town Q is equal to, as we've already found out, 180 degrees plus 65 degrees plus theta. So we look for theta and we add it to this to get the bearing of town R from town Q. So as we can see, if you use tan, tan will give us opposite over adjacent so that we can find our theta. So we can say that from the right angle triangle, tan theta is equal to 90 degrees, which is opposite, divided by 50 degrees, which is adjacent to theta. In order to find theta, we find tan inverse of both sides. So tan theta is equal to tan inverse of 90 divided by 50. Tan inverse of 90 divided by 50 on your calculator will give us 61. So if you pick your calculator, all you need to do is to press on shift tan, then you press on the fraction button, 90 divided by 50. Then you close the brackets and you are getting 60.945. But the question told us to give our answer to the nearest whole number. So to the nearest whole number, theta is equal to 61 degrees. But we are not interested in theta. Theta is not what the question is asking us to find. The question is telling us to find the bearing of town R from town Q. We needed theta in order to find that. So right now that we have been able to find theta, we are going to say that the bearing of town R from town Q, which is giving us 180 degrees plus 65 degrees plus theta, is equal to 180 degrees plus 65 degrees plus 61 degrees, which will be 306 degrees. So the bearing of town R from town Q is 306 degrees. A vector or vector quantity is any quantity which has both magnitude and direction. Examples are force, acceleration, etc. We learned in the video on bearings that bearings gives directions. For vectors, they give both direction and magnitude. So for example, if you take a distance bearing problem, bearings will give you only the direction, but a vector quantity will give you both the direction and the magnitude, which is the distance. Another quantity called the scalar quantity is a quantity that gives only magnitude but no direction. Examples are time, temperature, etc. In this video and the subsequent ones, we are going to concentrate on vectors. Just as we saw in bearings, vectors are also represented. Vectors can also be represented on diagrams. Vectors are denoted by a pair of block letters or capital letters and an arrow on top of them. For example, vector AB is written as AB with an arrow on top of it. So vectors are represented by capital letters or block letters. So vector AB is written as AB with an arrow on top of it. In the same way, vector CD will also be written as C, then D with an arrow on top of it pointing this way. Okay. What other thing can we learn about vectors? Vectors can be represented in two forms. The first one is the column or component form, where you have it in this way. So A and B. That is the first form. The second form is the magnitude bearing form, which is R and theta, where R represents the magnitude and theta represents the bearing or the direction. Don't worry if you don't understand most of these things. We will explain them as the video goes on. How do we represent vectors on diagrams, or how do we represent vectors graphically? We are going to consider for each case. So we will first consider for the column or component form. To represent vectors of the column form on diagrams, what you have to know is that A is measured along the x-axis and B is measured along the y-axis. So this one here, this vector here, can be written as if it is the coordinate of a point in the Cartesian plane or the xy plane. So when that happens, A represents the value on the x-axis and B represents the value on the y-axis. So A is measured along the x-axis and B is measured along the y-axis. So if you draw your Cartesian plane like this, or your x and y plane like this, with this point here as the origin, we know that this line here is our x-axis and this plane here, or this line here, is our y-axis. So if you have vectors in the column form written as AB, A, which is the first value here, is measured along the x-axis, and B, which is the second value, is measured along the y-axis. Now you can see that A here can be positive or negative. B here can also be positive or negative. If you draw the xy plane like this, we know that starting from this side here, if you are moving towards this direction, the values are positive. If you are moving towards this direction, the values are negative. If you are moving upwards, the values are positive. And if you are moving downwards, the values are negative. So If the x component or a is negative, move to the left. So what that means is that if you have a vector in the column form, if a is negative, move towards the left. If a is positive, move towards the right. In the same way, if the y component is negative, move downwards. If the y component is positive, move upwards. So when you come here, if b is positive, move upwards. If b is negative, move downwards. These sign conventions are very important. We are going to use them a lot when we are representing column vectors on diagram. So this is how to represent a column vector on a diagram. Let's go to the second type, which is the magnitude bearing form. For vectors in the magnitude bearing form, that is r theta. Theta represents the bearing and it shows the direction, while r represents the magnitude and shows the length of the line. So for example, this vector here given 3 kilometers 52 degrees. The magnitude or the length of the line is 3 kilometers and 52 degrees here represents the bearing or the direction. So what you have to do is that you measure or you draw a bearing for this 52 degrees, then you indicate the length of the line 3 kilometers on the line that you draw. Once again, we are going to take more examples on this, so you are going to get it very well. Remember that when you are drawing the bearings, all bearings are measured from the geographic north. Vector quantities are represented by arrow diagrams. So for the vectors that you'll be drawing, the lines that you will be showing will be arrowed lines or arrows. The length of the line represents the magnitude, and the arrows, the direction of the arrows shows the direction of the vector. So the length of the line represents the magnitude of the vector, then the arrow will show the direction. We have 6 questions here and we are going to solve it one after the other. So we take the first one. Vector AB, and is given in the column or the component form 2, 3. So when you have this, what you do is that you draw your x and y plane. So we see that on this plane, this is our x-axis and this is our y-axis. We said in the previous video that when the x value is positive, you move towards the right. When the y value is positive, you move upwards. So here we are going to measure. The starting point is point A, so we indicate it here as point A. This is our starting point, point A. You can see the direction that it means that we are moving from A to B. So the starting point is point A. So if here is point A, the first value, which is 2, it will be measured along the x-axis and it's positive. So we are going to measure 2 towards the right because it's positive. So 2 towards the right, positive. The next one is the y value, and that is 3. So you are going to measure 3 upwards because it's positive. Don't forget that when you draw your x and y plane like this side is positive, this side is positive, this side is negative, and this side is negative. So if this is positive, if the first component is positive, which is 2, it means that you are going to measure 2 to your right. Then because it's positive, the y is also positive, you measure 3 upwards. So you measure 3 upwards like this. What it means is that when we draw a line from 2 upwards and from 3, they are going to meet at this point here. Where they meet is point B. So where they meet is point B. Now we can draw our arrow from A to B. So it means that we have been able to represent this vector on the diagram. So vector AB, meaning that if you want to move from A to B, move from A, move 2 steps to your right, then move 3 steps upwards. You'll be able to move from A to B, because if you move 2 steps to your right, you get to this point, then 3 steps upwards, you are going to get to this point, and that is point B. So this is the vector AB, and we have been able to represent it on this diagram. Let's take another question. BC. So you draw our x and y plane or our Cartesian plane. Now you can see from here that we are going to start from B. So B is our starting point and we will be moving to C. The first component will be measured towards the x-axis and it's negative. If it's negative, you measure it along the left-hand side. So here is our left-hand side. So it means that we are going to move 3 steps to the left. So from B, we move 3 to the left. Remember this, we are not drawing this on a graph sheet and we are not drawing it to scale. So you can just choose any point as 3. But make sure that you see this one is 3 and this is 4. So make sure that 4 is longer than 3. Okay, so you move away from B to the left and you indicate it as 3. Then here the next one is Y, which is positive. So it means that you will still measure it upwards. So 4 upwards. Now you can see from here that 4 is actually longer than 3. It should be longer. Okay, so it means that if you draw a line from 3 upwards here and we draw a line from 4, they are going to meet at this point here, and that is point C. So we can join B to C. So what this means is that if you want to move from B to C, move 3 steps to the left, then move 4 steps upwards, and you'll be able to move from B to C. Let's consider the next one. Negative CD, and it's -5, -4. So you draw our x and y plane like this. Now x is negative, so it means that you move to the left. Y is negative, so you move downwards. Okay, so it means that we are moving from C. You will move 5 towards the left and you move 4 downwards. So if you draw a line from 5 and 4, they are going to meet at this point, and that point will be point C. Point D, sorry. So you join the line from C to D. Now look at the direction of the arrow. It's moving from C to D. So this also means that if you want to move from C to D, move 5 steps to your left, then move 4 downwards, and you'll be able to get from C to D. So you can see from here that the negative or the sign of the numbers gives us the direction in which we should move. Let's consider the next one, which is GF, 4, -3. So once again, you draw your x and y plane. Now the starting point is point G. X is positive, so you move to the right. So you move 4 to the right. Y is negative, so it means you move downwards. So you move 3 downwards, which is, as we have here, 3. So you draw a line from 3 to 4. You draw a line from 3 and you draw a line from 4. They are going to meet at this point here, and that will be point F. So you join with an arrow. Now you see the direction of the arrow moving from G to F. So if you want to move from G to F, we move 4 steps to the left, to the right, then we move 4 steps downwards, and we are going to get to point F. So as I said, we are not drawing this on a graph sheet. So you don't necessarily have to use a ruler to measure or anything. You just have to move some few steps away from point G and you indicate it as 4. But make sure that 4 is longer than 3, as you can clearly see in this diagram. The next example given to us is in the magnitude bearing form. Now if it's in the magnitude bearing form, you are going to draw the diagram for this bearing. The diagram for this bearing, 140 degrees. We've done a lot of this in the video on bearing, so I'm going to go straight away and draw the diagram. So 140 degrees, we are moving from X, so this is our starting point. Don't forget that we measure bearings from the geographic north. So if you are measuring this 140 degrees from the north here, which is the 0 line, it means that 140 is going to be between 90 degrees and 180 degrees. And if you add 50 degrees to 90 degrees, you get 140 degrees. So it means that this bearing here will be drawn as this. Now we are moving from X to Y. So it means that our starting point is X and the ending point is Y. The length of the line is 5 kilometers. So you write it on the line as 5 kilometers. So you see in the magnitude bearing form also, we can represent the vector on a diagram. Let's take the last question. M to N, and that is 10 kilometers 295 degrees. So once again, you draw the diagram for this bearing 295 degrees. 295 degrees will be between 270 degrees and 360 degrees here. So it means that we are starting from M. If you add 25 degrees to 270 degrees, you get 295. So you measure 25 degrees in the clockwise direction from 270 degrees. The ending point is point N, and the length of the line is 10 kilometers. Once again, you are not using a protractor, and you are not also using a ruler, so you don't have to get everything accurate. You just have to make sure that your diagram is appropriate. So 25 degrees should not be more than half of what you have here, because we know that the whole thing is 90 degrees. So 25 degrees should be something smaller. Okay, so you have been able to represent all these vectors on the diagrams. We are going to apply this as we go on in our studies.